So yeah, I guess there's a few things we mentioned in the group that we could chat about, but a lot of it kind of revolved around this example of like a balloon, things like that. I also had some kind of thoughts on that I'd be up for sharing at some point, but I don't know if you wanted to start, Jeff.
No,
We were
I
drawing
just
some stuff.
wanted, I remember last week we talked about uh, one of the things we had to just figure out once is how learning is, um, how we solve the problem of every column has to learn every model.
Yeah.
And then it became really obviously a difficulty problem when we're doing our behavioral models. And so I have like I think I had the general direction to solve that. So when we get a chance, I can talk about that. But I don't have to do that. I can do that after we talk about balloons if you want.
Okay. Yeah. Yeah. Maybe, I mean, I could talk about what I was going to say because I think it's pretty brief and we might all disagree. And then I think it's a nice segue into maybe what
Okay,
you're
so
going to
so
talk
what's
about.
your topic is what about balloons?
I guess
That was
it's
it.
about balloons, but it's also about this thing about model sharing.
Okay, all right. Well,
And
then it's
basically, it's just the suggestion that maybe we're making it more complicated than it needs to be, and kind of what we have is in some sense sufficient, at least for this stuff.
yeah,
Because when we're talking about like the stapler opening, there's this issue of like, okay, when you're observing the behavior, you might just be observing it for this location, and kind of learn that. And then later you see it at this location and it's like, how do you generalize? And so that's where this kind of question comes in of like sharing the models of like all the different locations that have been learned. And then I guess the balloon was kind of a similar issue of how do you describe this like complex distortion of the balloon kind of increasing in size, but it's not just increasing in size, it's doing lots of different things, as you say, Vivian, like if you had a logo printed on the balloon, that would be doing complicated things.
well,
But I guess
I understood the balloon problem to be that all the features of the balloon are moving at once. And how would
And
that work in a primary region? Is that correct?
that they're moving at once, but they're not moving together in a consistent way. Like with the logo, they're all moving in the same direction, but with the
Right,
balloon, they
right,
all move in different directions for different amounts.
right.
But yeah, so I guess what I'm just thinking is with the stapler top or something like that, we've talked about how if you're modeling this as a child object, you could then vote on the state of this child object as a whole. So where that is in space, what its orientation is, and things like that. And if that's kind of the information you're passing up, and that's the information that's forming the basis of the behavioral model in the higher level learning module, then later when you see when you're looking at a different part of the stapler and it's showing kind of the same behavior, as long as you can still infer the state of this child, that representation will generalize. It doesn't matter that when you first learned it, you were at this location and
Right.
now you're
I think
here
that
because
I thought
you're
that's what
describing it at the child
I
level.
thought that's how we ended up last week. What felt pretty good was that the lower learning module is basically inferring the child, and as long as it's inferred the child, it doesn't matter where it's looking.
Yeah,
And
but then
then
you don't need to share models in that case, I don't think, because the only instance you would need to like basically the description of the child is generally sufficient. I think if it's not, if it's such a complex behavior like someone dancing or something like that, there's multiple children and stuff like that,
well, right. I
then
think that's
that's the case where you probably do have to attend to all the locations to learn
right.
the
Right.
behavior.
So right, if there was I mean, even initially, you may not know that, I can think of two stapler tops, or several, many. One is
Yeah,
the whole staple top moves at once, and the other is it divides in two and it goes this as it opens, or another one it rotates this way as it
right.
opens. So you can think of all these things. And so all those situations require multiple observations. Um, and you just really hard to imagine if I had a single column, I'm looking through a straw, how I could possibly learn those. It just seems really, really hard.
Yeah,
If we assume that there's a single child, and I know, by the way, I have to know that that's the child, right? That wasn't, I guess we don't know which, in the stapler, we may not know there is one child, and maybe there's 10 child, and maybe the stapler bottom's rotating. So it's a little bit more complicated. We can't just assume that the stapler top is
sure.
one
Yeah,
thing.
and I think how we kind of segment it out and represent that is a separate and kind of unsolved problem. But I guess I'm
Well-
just saying that I think that if we have that kind of segmentation and we're kind of representing the state of the child and we can kind of vote it on it and things like that, then I think a lot of these concerns around kind of sharing models between learning modules disappear.
Well, I think that was more of the question. We started off by saying, how do I learn, even a single module, learn a behavior? And the question then was, how could it observe all these things at once? And it can't. So I think if we knew that you're going to parse the staple into two parts, and one part was moving, and there are two columns, and they knew which was the parcellation, then that would be easy. Well, it would work. But then again, what if there's multiple pieces moving at once? Then it gets harder. It's like,
Yeah, I guess when we're thinking, it's just that, like, if you imagine you're looking at kind of a stapler.
Wow, this is cool. So we're using our logo pattern as a template for multiple columns. That's cool.
Exactly, for voting. So you imagine each one of these columns is seeing kind of a part of the stapler.
Right.
If this part starts moving, basically all of the columns that are seeing that are getting some information about a particular state of the stapler. They don't necessarily know that it's just the top, but they might all be kind of agreeing that, okay, yes, stapler at like the object level seems to be moving in a consistent direction, or rotating in a consistent direction. So that it feels like that could kind of help them, like all of these learning modules basically be talking about the same thing. Like, okay, and then if there's, I don't know, let's say that this, while the top opens, this one shifts back and forth.
Well, wait,
then those learning.
This is the
learning
child
modules
object. This is the child level we're looking at here.
Yeah, I guess that's the child shown.
So remember,
here.
The child level at this point is seeing all parts of the stapler. So we've somehow pulled out the parts that are moving versus the parts that are not moving.
Yeah, so
right?
I think I guess what I'm just saying is, like, we kind of talked about how the first level of the representation of the child object is just the same. It's still just a stapler, but then we kind of have to somehow, like, kind of attend to part of it, or somehow kind of like cut off part of it.
Segment it, right.
But segment it. But just the first part, I think, is straightforward, that all these parts are kind of talking about the same stapler, because their stapler, everything they're seeing is moving in a unified way. Whereas all the ones that are talking about a different part of the stapler, they're experiencing basically a different stapler. It's almost like it's two different objects.
Well,
because
the
other properties associated with it are different. It's this stapler isn't moving, and things like that.
Right. So I think this begs the. I mean, there's two issues here, right? One is we're just trying to figure out how do we segment this so that we know that the child object is the moving part, and pay no attention to the other ones. Right. I mean, that's part of the problem, and.
Yeah, I guess what I'm just trying to get at is, like, this is how one learning module here could be confident there is a stapler that is moving, even though it only sees part of it.
And this
it
is
doesn't
doing inference, right?
Yeah,
this is just inference.
Yeah, this assumes we have a model of the inference, but we're now learning the behavior. So we have a model of a static stapler that we can leverage.
Would be learned in the higher level column in this case.
Yeah.
And then, so are you suggesting that we would use the votes to learn where to lay down points in the behavior reference frame?
No, just that the votes help a single learning module recognize kind of a state of the entire child object.
Oh, okay. Yeah.
Like that it's changing in some ways, and that is what's passed to the higher level, and that's what's.
Here's the problem: the stapler, before we've done anything, we don't know what parts of the stapler are going to move and which parts don't. It just you got to forget. We know that, you and I know that, but the system doesn't know that, and so when something starts moving, the one column has no idea what is moving. It just says the thing I'm looking at is moving, but that could be the back half of the stapler or the front half of the stapler, or it could be the logo on the stapler. It could be, we don't know it's the top half of the stapler because we don't know about top halves yet. Something is
But that- I
moving.
think-
Yeah, as far as it's concerned, the whole stapler is moving.
Well,
But
yeah, but
I
it
think-
doesn't know.
I think what Niels is suggesting is that, correct me if I'm wrong, but as far as I understand it, and I think it's a good point, that if we assume that the lower level column has learned a model of the stapler,
Right.
then having many lower level columns with associated to all these patches means we can do flash inference of the stapler and its orientation. So we can very quickly know the orientation and ID of the child object and pass that up to the parent
Right.
column, which learns the behavior. So
But
that
I see a
behavior-
problem with that. We don't know. Imagine many different parts of the stapler might be moving now. And that single column can't say different, you know, it would come to one conclusion looking at one place and another conclusion looking at someplace
Exactly.
else.
But that's the thing. So it's basically going to be saying, maybe a clear way of showing it is basically we're going to have two models of the stapler as far as low-level columns are concerned. So the learning module here, sorry, give me 2 seconds. Oh, that's slow. Basically, the learning module here, what the arrow's pointing to, it's voting with a bunch of other learning modules that are seeing the same thing. They're basically doing flash inference and saying, oh, the stapler's at this orientation. A learning module here is voting with all of these and saying, no, I see a stapler at this orientation. So those learning modules are going to basically be thinking they're seeing two different objects. Like it would be as if there was two objects in the, you know, if
Well,
it was
I
these
don't
two
think- I think-
objects, they don't agree. So they're talking about different objects. And so all of they're going to pass up, like all this learning module is going to pass to the next level, is a stapler at that orientation. But if we look down here, it's going to pass, okay, there's a stapler at this orientation.
Yeah.
They would still
not
have
sure we-
conflicting votes. I'm not sure if they would actually
Right.
Yeah, they would
converge.
exactly, they would disagree. I don't
They
think
may
they would
not, they may
converge. I
not
mean,
reach a
they would,
conclusion.
I guess they would agree on
Yeah.
ID, but
But
like
I think it seems to me the only way you get them to agree is you have to mask off the other parts. That seems
but
to-
why is it any different? I mean, I think the masking becomes important when we want to make like predictions and things like that.
No, I think even just I mean, what if I'm a learning module and I see something locally moving, but everybody else sees the stapler. My vote will be overshadowed. It'd be like everyone's voting and saying, no, this is stapler. You just got some weird thing going on over there. You know, it's like we're all agreeing. This is
I mean,
stapler.
I feel like unless you attend to that and you pay particular attention to that, that's going to be kind of like a blind spot. Like you probably wouldn't even notice that. But if you're attending to it, then that learning module will basically be saying, I'm definitely not seeing a
Right,
stapler.
so
I'm seeing like
attending-
a small piece
Attending
that's doing
is-
something
is-
else.
Attending is including masking. Attending is saying, this is the part that's important. I pay no attention to the other parts. And so that's where we came up with this idea that the parent has to say, or somebody has to say, attend to this section, ignore everything else. And that's essentially saying, mask out everybody else. You know, these are the only columns you
Right.
care about. So I'm not sure. Well, I don't think we can get rid of the idea of masking. I'm arguing for that.
I don't want to either. Yeah, I agree.
Okay, so then
I guess I'm just arguing. Yeah, I think
so let me finish my argument.
I don't think we need to share models. Is I think what I'm arguing.
Okay, but I think we have a problem. We can talk about how we're going to address the problem. The problem, as I see it, is as an object behavior unfolds, there's lots of things that might be moving, and they might be moving in different directions. I don't know how many child things are changing, and therefore I have to. I can't attend to them all at once. I can't attend to all these things at the same time. That's the thing I was struggling with. Imagine if the top of the stapler didn't raise, but well, maybe as it went up, it became like an arc. It bent, it went up and it turned like a whoop, it bent, and then went flat
Yeah.
again, went up. I mean, so there's a lot of things going on there in the behavior that I can't say, oh, it's just part of the stapler moving. It's like, oh, there's a lot of changes going on.
Yeah, and I guess that gets to my other one, which relates to kind of the balloon, which, yeah, I think it's an interesting one to think about because
before we start talking about the balloon, we should make sure we all know what we're talking about.
Yeah.
I actually made a couple of animations for it, but
oh wow.
I don't. If it's a quick point, Niels, you want to make, you can.
So maybe Niels, I'm not sure if I understood your point. I think the point, and I thought we come to some sort of agreement about this last week, is that especially during inference of a behavior, that was the thing I was focused on. We can make correct predictions if we know that the child object is moving. We don't have to be observing one part. If we know that part, how that part is moving, then we can make predictions about the other parts of the child object. So if I'm only looking at the middle of the top, I can predict what the end of the top is because I just know the whole stapler has moved. I thought that's the conclusion we released last week, or at least that's how we left it. And
yeah, I guess what I was, at least in my mind, it's not clear yet how that would work if an object is actually deforming, like if the features are moving in different directions.
Such as a balloon.
Yeah, exactly, like the balloon.
Okay, so I'm not sure.
and
I don't know if I missed something, Niels, if there was something addition on top of that you were really a point you were trying to make.
No, maybe I misunderstood your concerns, but I felt when you had argued for why we need different models, or sorry, to share models rather across columns, it was this issue of like, if I've only learned when looking at this small part, how do I generalize when I see this other part?
No, I think we came up with a reasonable solution for that, and I think you just reiterated it.
Yeah.
Maybe in a little bit more detail, but I still think there's an issue of how a single column can learn the behavioral models when you don't know what parts are going to be moving and how they're going to be moving. So
I agree. Yeah, if it's learning like through the straw or whatever. Yeah.
Right. So
which I think we've also argued several times. Like, is that even possible? Like, can we really learn behaviors looking through a straw?
So I've always felt that can we learn a morphology model looking through a straw? Yes, you can. It's pretty slow.
Right.
And I've argued that I don't think we do that. I don't think every column has to view every part of an object. So somehow we can train a whole bunch of columns that that they don't all have to experience every location on an object. But it wasn't a hard requirement because a single column can do it by moving slowly. We've done that. That's what Monty does. So, but now with the behavioral model, it gets really, really hard because we don't have the time and the luxury to go around and look at all the things and say, who's moving, which way? It's all going by really quick. So then it just forced the problem upon us. That's how I felt. And so I felt like, well, there's always a problem, but it wasn't really big. We kind of hit it, but now it's in our face. And so it was a learning problem. And I think we did solve, as you just talked about, we did solve like, oh, once I've learned it, how do I make predictions? Okay, I'm with you. Yeah, we can now predict. Even a single column can predict, but how did that column learn the correct?
Well, yeah, and I guess what I was arguing, and I'm not saying this is anything new, but just emphasizing that even during learning, voting is still relevant.
Well,
that's where the flash inference for the state of the whole object can help inform learning.
That assumes you know what parts of the object are moving.
Right, which I guess in my head, I think it's fine that we would just get these islands of agreement. And it's just the same thing as looking at multiple objects.
But now we take the balloon and the bending stapler.
Yeah.
I can't do that. I can't vote.
Well, then the balloon. So the first thing was, it was two ways that I feel like maybe we're trying to make life harder than it needs to be. First one was, I think, flash inference helps a lot train learning. The second one, in terms of things like the balloon, like you, I think, wrote, Viviane, how like, okay, it could just be like scale, but that's too simple because distortion is more complex than scale. But I was just thinking, do we actually model it at that level? Or would we just model it at a coarse level like scale? As in, we're talking about like, okay, how to make accurate predictions, but you know, when we look at a balloon, we're not expecting to see a particular contour at a particular angle or whatever. We're just expecting roughly as it inflates to see something that is consistent with our internal kind of predictions. So just whether, yeah, and maybe whether this applies to a lot of the distortions that like our behavioral predictions, unless we've spent a lot of time and become like an expert with a particular behavior, they aren't necessarily going to be as good as I think sometimes in our thought experiments we are kind of projecting them to be.
Right, well, the
But,
balloon would be that case, the t-shirt would be that case, but, you know,
Yeah, like the t-shirt.
take
well,
my
yeah,
stapler
I mean,
top
I
that bends.
purposefully didn't talk about the t-shirt because the t-shirt is so complex, but the balloon is so simple that we all know how a balloon inflates and how it changes scale differently at different locations and how it would distort if something is printed on the balloon. Like we
But
have a
do
model of
we
it.
really are we really able to predict that, or is it more like if the logo, like when the logo is distorted and we look at it, we just see, oh, okay, it's a distorted logo. Like now we're more learning a new distortion. It's not that we are like, wait, this distortion was like inconsistent, if you know what I mean. Like,
Right, right,
I
it
mean, I
just could
can imagine
follow.
it in my head how it would distort. Like I don't have to be recognizing it.
Mm.
I mean, well, okay, maybe your imagination's better than mine, but if I like imagine a logo distorting on a balloon, it's a pretty fuzzy mental picture. It's not like I have a crystal clear sense of like
But like if
how
Right.
you
the logo
imagine there's
deforms.
a checkerboard pattern printed on the balloon, you know how the like which checkerboards would uh, get larger and which ones would not get much bigger.
Well, you know, it's, now we're getting back
I
to
feel like
composition.
I had to like mentally attend to the top and the bottom, and then I could roughly say like, yeah, okay, at the top the scale is increasing more, so I expect them to be bigger. But it's not like, again, I have a clear picture of like, oh,
Remember,
acute angles are becoming
one of the
obtuse
things we had to
or
solve with compositional objects was the logo wrapping around the cup, because that's a distortion, just like the balloon. And so that was solved by not distorting the logo, but by assigning it a point by point on the morphology of the cup. So the logo on the or image on the balloon could be just like that. It's like we're not really distorting the child object, we're just creating a new parent morphology and the point by point.
Yeah, so I get
Finance.
that. I think that's a
Can we
valid.
start with maybe Vivian, you want
I
to
think.
describe the balloon problem? Just make sure we
Oh
don't
yeah.
follow.
Just before I forget the point, the main reason why I didn't go with that solution is learning it on a point-by-point basis requires active learning and specific connectivity. So we can't reapply a behavior to a new object just out of the box. You have to learn the associations on each location.
Well, only if the balloon was really an expansion of the reference frame. And you really were a scale, and you were just maybe the balloon blowing up is really a scale change, then you wouldn't have to require any new learning. Basically, the points on the balloon are now further apart, but they still correspond to the correct points on the logo or whatever's on the balloon.
Yeah,
You know,
not 100% convinced, but I guess before I pull up the
I'm not
slides,
trying to convince
do you
you. I'm
want to
just
go
trying.
over? Do you want to go over what you prepared on Excalibur first? Because I feel like
Me?
if I start the slides now, it will probably end up being a longer discussion, given how it
Sure.
usually ends
Yeah,
up
well,
being.
that's assuming mine won't be a long discussion, but I only have a few images. It's in the, how do I do this? Do I have to share my screen? How do I do this here? I share my screen.
I think that would be best, then you can point
Yeah,
at stuff.
and then I only want to share the second screen so I can still see all your lovely faces. And it says I'm sharing a screen. Do you see that now?
yeah.
Yeah.
All right, I'm just trying to get my, okay. So this is just, I'm assuming you're all seeing the same thing. You can see my cursor, or should I go to the lasso?
Yeah, we can see the cursor.
Okay, so here's a single column with one or, with a learning module. This would be, let's assume it's a, a behavior or a morphology model or both. And so we start off by saying a single learning module must see every featured location. I mean, it doesn't have to look at every location on an object. It has to look at ones where there are features. And if it's a behavioral model, it has to look at every location at every active point in time, right? So that's a lot of burden to have a single column learn. I've also often felt like, oh, there has to be some sort of shared learning or learning transfer or something like that. And in the past, I've talked about this second image here. I said, imagine you have a whole bunch of columns that are in the same region. Only some of them are beginning active input. Those are the ones with the green, let's say those are the ones with the green squares. And others wouldn't be getting any active input. They're not observing part of the object. They're looking at some space in the object, but there's nothing there. And so one way you could do is you could say, oh, well, the ones that are learning could be sharing what they're learning with their neighbors. That would be speed things up. So this column here is learning something. This column here is not getting any input. But this guy says, why don't you learn what I'm learning? You know, we'll share information and you can learn the same thing I'm learning. If you're not doing anything, why don't you be productive? You know, that kind of thing. So I often felt like this, but I never really liked it. And after thinking about it yesterday, I think it's not right. I think what's going on is something completely different. And that's going to be shown in these images here. Imagine, whoops, what the hell just happened? You know, sometimes it just switches to another template, another scene. How does it do that? I don't know, scrolling around this switch. Okay, so here we're now looking at a typical hierarchy. This is drawn like a cortical hierarchy, but it'd be a hierarchy of learning modules. These are regions, so there's multiple learning modules in each of these layers here, right? This is your class, so there are going to be many, many learning modules here. I'm not showing them. And we're just going to make the following assumption, that the things at the top of this hierarchy are very fast learning. The top is instantaneously learning. That would be like the hippocampus. And as you go down, they get slower and slower, or just they're all slow. But the bottom here, things are learned very slowly. So you're not going to learn quickly here. And there's a lot of evidence, and I've talked about this before, that when you first learn something, you learn it in a way that's modality independent. So even if I learn what a cup looks like with the tip of my finger, I can visualize it immediately, and I can make visual inference, even though I've only touched it. Which is not consistent of learning in a single learning module, even a single region, a low-level region. And so, and this sort of standard neuroscience dogma is that when you learn something, let's assume it starts at the fastest. You have to information enters at the bottom here, but it goes up through a series of levels, and the first learning module you learn is at the top. And this requires attention. So part of attention is routing where you want information to get to transfer. Like don't pass this information up. Don't pass this information up. Only I want to start here and get that information all the way to the top. So I have to go through some number of learning levels here to get to the part. These guys all know something, but they're slow learning, so they're not going to learn right away. But they already have previous knowledge. So by the time I get up here, I'm learning I'm learning fast learning of existing compositional objects. So I walk into the dining room, I'm looking where the plates are on the table. I know what plates are and glasses and forks and the tables. So all I'm doing up here is learning the arrangement of those high-level objects. But it doesn't really matter. What's going to happen, you're going to attend to something, information is going to flow up, and you're going to learn this model up here at the top. Because this is slow learning, these modules are slow learning, they may start learning something, but they're in the first initial thing here, they're just not going to have enough time to do it. Now, once you've learned this model at the top, which is in some sense independent of where the information came up from, right? It doesn't matter if it came up from over here or here or here or here. It's independent of where it is on your skin or which modality you used. You've gotten to somehow to this higher level model that's modality independent and location independent. Now I can infer from a different direction. For example, I can, if I touch the object with my finger here, I'm now looking at the object, I can infer it through vision because I follow the same channel up here and I get to the top, I'm using the same model I learned earlier, which is modality independent and location independent. So infant can use different modalities, but I still have to attend to say, okay, attend to the visual system here, and I can now recognize the object I learned by touch. And then how do these guys learn more sophisticated models? As you do this, these guys are all trying, as information flows up, they're all trying to learn models. They're just slow. So one shot's not going to do it. But if you practice over and over and over again using a specific set of columns going up to the top, then these other modules will learn models too. So if I end up spending all my time just not looking at coffee cups, but touching coffee cups, then I will get really good at touching coffee cups, and I will learn models lower down that are touch-based. So I don't, in the future, I will not need to go all the way to the top. I will not need to attend to the cup because I've learned what it by touching it so many times, I've formed models down in the touch regions here that are sufficient, and I don't need to attend to it. In fact, I can learn down to the lowest level here, or just the lowest 2 levels. So that frees up my attention. I don't need to attend to the whole stack here. I can be driving the car using these low-level models while I'm thinking about some concept, talking to you, and so my hippocampus is involved in our conversation, but my driving is down here. So this involves no transfer learning. No models are transferred anywhere, but it does say that I have to learn multiple models at different levels. But I don't want to learn multiple models at all levels. I only really want to learn at the ones where I really experience it a lot, so I don't need to learn what letters feel like. I need to only learn what letters look like. Once I've done that, I don't have to attend to it at all. But if I wanted to feel what letters feel like, if I wanted to learn Braille for the first time, I have to think really hard about it and use the whole stack again. So the basic idea is there's no transfer learning, but we do need a way of many learning modules pick up to learn slowly. But until they've learned slowly, I can rely on the higher level models. So I can immediately start doing what looks like transfer learning between touch and vision, but it's not really transfer learning. I'm just using a sort of modality independent model at the top. All right, so I've said that's the basic idea. I don't know if I've said it very well, but this to me sort of is a direction of how I think about learning now, and I don't have to worry about does every column have a chance to see everything.
So in the beginning, when it just kind of passes the information from the lowest level to the highest level, when it passes through the intermediate levels, what are they doing? Like, are they just outputting the same thing that they're getting as input?
No, it depends what they know. If they say a child knows nothing, then none of these things are learned at all, and you just came out of the womb, so you'd be passing up the most basic. I don't even know what you'd be passing up. It would be the most basic stuff. But after you've learned a whole bunch of stuff, as the information goes up, this guy will say, look, imagine I'm trying to learn the logo. I've never seen the logo, so I'm attending to the logo. And maybe I don't even know the word, so I'd attend to each letter at a time. So I don't know where letters have been learned. Maybe letters have been learned at this level. Maybe letters have been learned down here because I do a lot of reading. So I would be passing up the letters, and maybe then this would be like a syllable, but then I would be learning the word up top here for the first time. So it's not like I'm passing up the raw data. The raw data can very quickly convert it to previously learned objects, but in the end, you're trying to learn a new configuration of child objects. And so what child objects are passed to this top learning module, it depends on what you've learned before. I could have learned the whole word Numenta, and I could be passing up the child object could be Numenta, and I'm learning the logo as a composite object of Numenta plus an image. Or I maybe have never learned the word Numenta, as I might be passing up syllables, or I may be even poorer reader, I'm passing up letters. Or maybe I'm looking at a different language like Hangul, and I don't even recognize the characters, and so I'm passing up individual strokes up here, trying to learn what the strokes look like. So it just depends on what's previously been learned here. They will try to do compositional structure, whatever they've learned, and pass up like, okay, the new arrangement of these features that are composite objects, and how sophisticated they are depends on what I've learned in the past.
Yeah, I guess. Yeah, the main thing I'm just unsure about is like that each of these layers will try to learn compositional structure, and each of them will try to pool features into a condensed representation, like the layer 4 input into the layer 3 output. So it just seems difficult to imagine that they would pass forward basically the same thing if they haven't learned about it before. Like how is just a stroke would be passed through multiple levels of hierarchy and remain that.
Well, I think there is you're maybe asking about a startup problem, like how does the system get started? Because it seems to me it would work very well once you've had some kind of learning in the system.
Are more the hierarchy, like where I guess are the, like to what degree there are direct connections from lower levels of
Yeah,
the
yeah,
hierarchy to the
that's
hippocampus,
more
which
the
Well,
thing. Like,
all right,
uh,
right. That's a great point. I didn't show that on here, but I did write about that, thinking like I've shown the green arrow has to go through all these things. It's possible that the voting layers are shared more globally. And
yeah.
so if the voting layers are shared more globally, you could skip over these layers. You basically at the top here, you're saying, oh, who's voting on what, but I don't know how that would work.
So yeah, I guess what I definitely like this way of thinking about it. It seems to solve a lot of issues to use hierarchy and slow and fast learning for it. I guess the one thing that I was thinking about differently in this framework was that I was thinking in the beginning you would pass the lower level features very high up to the fast learning modules, but directly without them passing through several layers of hierarchy and trying to compose them out of objects. And then the way you learn them lower down would be top-down predictions, basically, that the higher level quick compositional model can top-down predict, say, okay, I have stored this cup ID here, and whenever I
But first
sense
of
the
all,
cup
let
ID,
me challenge your first point. I wouldn't want to send up low-level features if I already know what those low-level features represent, right? Again, I'm looking at the dinner table. I don't want to pen up edges of plates if I know it's a plate. So why would I? I mean, I should just pass up. It's a plate. You know, it's like don't
well,
worry
yeah,
yeah,
about
this
the
is
edges.
like earlier in learning. So maybe it is, as you say, Jeff,
Right.
more
I
like
use the
going the
example of
startup issue.
I
yeah,
use
no,
the
I
example
mean
of
we can stick with the plate. Like we know the plate already, but now we have to go through 3 more levels of hierarchy. Like what are you gonna compose in those extra 3 levels before
I
you
don't know. That's a good question. I don't know, and that's what brought up the question of like, is there some way of is the hierarchy strict like this, or is there really more of sort of a pooled understanding of what the current object is, and that pooled understanding goes up? I don't know. That's a good question. It remains to be seen, but right. I didn't say this was all worked out. I did feel like this is the right direction, is what I feel.
Yeah, yeah, I agree.
Right. We could start out with you don't need 8 levels of hierarchy. You could just have 3, region 1, region 2, and hippocampus, and see how it works. That was the way I probably would start thinking about it.
Yeah, in some ways we've kind of started with the hippocampus anyways, given how fast our models currently
Yeah,
learn.
we have 1 column in the hippocampus. That's what we have right now, which is fine. I mean, like we can do all these variations that biology can't do. So I've had a problem with that at all. And we can turn up and speed up and slow down learning all we want, right? We can have a single learning module say you're not learning now, and the other time say you're learning everything instantly. So those are all fine.
Yeah, at least we have hyperparameters we could use to slow down learning with the grid object models.
Yeah, but I really like this because this explains a lot of stuff. It explains why you have to practice to get really good at something, because the memory at the lowest level of the hierarchy is very precious, and you can't learn everything everywhere. Like again, like if I'm typing, these are very low level representations. If I just try to type by using, shifting my hands on the keyboard 1 key over and say, okay, well, you're just starting in a different home position, but you know where all the letters are. It's impossible, right? It's because I've learned very precisely which finger is moving which direction for typing letters, and that's it. And also one more point, and I'll get off my horse here. I thought about, I find as I get older, it's really interesting. I'm forgetting how to spell words, complex words. I'm always like, is it this way or is it that way? I can't remember. 2 L's or 1 L. And but I can recognize the word and I can recognize if it's wrong. So it's like I have these low-level memories of reading these words, and I know exactly what they look like. But if you ask me to spell them out, which is sort of a, it's like that requires attention. That requires like a model higher up. Like, what is the spelling of this word? That's not going to be down in V1. That's going to be really high up in the hierarchical cortex someplace. And I might have forgotten those because I haven't exercised that enough recently, or my memory's failing. But if you stop exercising the components and you just sort of learn the whole thing, you can forget the components that you originally learned it with. It's just an interesting observation. I can come up with others like that too. So the point is, you can still have these really good memories lower down, but forget the original ways you got there.
Right. Yeah, and I like this point about that, there is still a utility to these lower level learning modules that it's hard to get, but in terms of like the lack of attention stuff,
No, I think
or like being able to act without as much attention.
Right. I think, as I said many times, I think V1 is right where I recognize small letters, even words are happening in V1. So there's a lot of utility there. Anyway, I think I've said.
And I guess I think you kind of alluded to this, but maybe just to clarify, kind of, in order for this to kind of generalize sort of zero shot for a new modality, I guess you require some amount of like kind of co-learning of in the highest level, again in this kind of startup phase of different modalities, so that you basically understand that, like, okay, when I feel like a contour, that this is what a contour looks like, so that basically in the highest level it understands that those two are the same thing, and it can predict
somewhere,
one
I don't know where,
given the other.
I don't know where it predicts that. It doesn't have to be up the hippocampus, but somewhere it's really clear this happens, right? You're touching an object with your blindfold on and you can visualize it. So so somewhere up there, there's a convergence. This is classic neuroscience dogma. There's a convergence of modalities. We don't have to even think about it. We just said there's a convergence of learning modules, right? And so I didn't even break these pictures up into different regions.
Right.
It's just more like there's a big collection of learning modules, and you're picking out some subset of them. Well, some subset could be part of the retina and another part of the retina, or it could be a part of the retina and part of your body, skin, or something like that.
I mean, for something as low level as like how a surface or an edge feels and how it looks like, couldn't you also just use voting connections between the lowest level to kind of
but it's the compositional recognition.
Right.
So like you're now looking at like a new, or like you felt like an entirely new object, so it's a new combination of contours, and then now you look at it, you can recognize it. And I'm assuming that's because basically like the input representation at the highest level or a higher level or whatever is kind of common between those. So it's like it's like, okay, I'm getting contour, and then I can predict either contour in vision or in touch. And I guess it kind of fits as well with like I think there's some studies where they took congenitally blind children in India with cataracts from birth, and or like early in childhood, fixed the cataracts, and then they showed like how much they struggled actually to do this versus how we would. So like they would feel a pyramid, which they could recognize easily, but then they would see a pyramid, and they really struggled to connect those two any more than like a sphere versus feeling a sphere versus seeing a pyramid.
There's a whole book. I don't remember. I read the book. It's by a guy who went through this. And it turns out that some people who have later in life, when they enable their vision, they have regretted it, because it becomes this impossible distraction for them. They can see things, but they can't internally process them. And literally some people have gone crazy. I think some people killed themselves because it was so bad. And so this guy wrote a whole book about it. He went through the process himself and tried to describe what it was like. And but it was along those lines. It's like if you do this later in life, not only is it initially bad, but it may not ever get good. And it becomes it's like this sensory input. You could see things are happening, but you can't understand them, and they can't correlate them with other stuff. And it was interesting. Let's not spend too much time on that one, but all I want to point out was, I think this general idea is probably right, almost certainly right, is that there is no transfer of learning. It's just we have this scheme of which we learn slowly at the bottom, fast at the top, and then through practice we relearn models lower down in the areas that we practiced a lot.
And so just to kind of tie it back to what originally motivated it, how would it solve learning a behavior quickly without observing all the locations on the behavior? Like, do you think there's some convergence of the input at the higher level?
I don't know yet. I haven't even gotten that far. All I now is all I'm going to say is that there's a general tool about how to think about learning in multiple modules, and why I don't have to, this tool says why I can learn what a cup feels like using my right hand, and then later recognize it with my left hand, and I didn't have to pre-train all those columns. It's just a general philosophy of how you about doing that. So I haven't applied to any specific problem yet. So like I haven't thought about how it works with behavioral models.
Okay,
But
yeah,
now,
just
that would be
to
the
make
next
sure I
thing to
didn't
do.
miss that.
No, but that would be the next thing to do. At least now I have a tool to work on it. I didn't like the tool I had before. I didn't think it was right. Like, and I think we need a tool. I don't think we can solve this by just assuming that a single column is zipping all around the world all the time, learning everything. I mean, we can do that in Monty. That works fine. Monty, we can skip all this. In fact, I want to make that clear. This is the brain's way. We don't have to do this way, Monty. There could be many other ways of doing this, perhaps. But at least I want another way of thinking about it. Okay, so I'm done.
Time for balloons.
What causes the balloons?
Like I just occurred to my thought, like, can I try to like go through how like I'm trying to imagine myself just like trying to learn behavior by only looking through, like through a straw, like how that might go. Like I'm not sure if it's like
I don't think you can. Hoji, I don't think
not in
if the
not
behavior
in
is,
one go.
I think if the behavior is complicated, let's
Mhm.
say the behavior involves multiple things, like the stapler opens, but multiple parts move in different directions, not just one piece. I think it would be extremely difficult for you to be able to observe the behavior through a straw and then see it again looking someplace else and know it's the same behavior, or maybe not a different behavior. Because
Yeah.
I think it's
that's the
maybe
problem.
one way it can be simplified is if it's a behavior you can control. So if you're the one opening and closing the stapler, you kind of give yourself the supervisory signal of when you're changing the state, and you can give yourself time and know where in the sequence you are.
Right.
So for one, if it's like a really simple thing, like just pushing down a button that you can sense at one location, basically, I think it's no problem to learn it in one column. But then, yeah, if it's like a larger behavior, I think being able to control the behavior yourself might be
Right.
an
Right.
aid.
If you knew, for example, that's a great observation. If you know that I know that this is the same behavior because I'm controlling it, and I can go fast and slow and back up, and like I'm the staple, I'm going like this, like Link, whatever. And then whereas if the thing is moving on its own, and the thing's moving on its own, and you don't really know if it's the same behavior or not, a different behavior. Like imagine
And
trying to
I mean, it might be how you learn most of the behaviors. Like Link can spend an hour just opening and closing and opening and closing and just like going.
Yeah, but let's try to
faster.
imagine. What's the difference
Yeah.
between someone walking, running, doing jumping jacks, 5 different behaviors, right? And if those behaviors require looking at all the limbs at once, because the individual limbs may be shared on different behaviors. Well, trying to discern someone, running versus walking versus, I don't know, moonwalking, or, through a straw might be really, really hard, right? You wouldn't know which one's going on. You see the leg's moving this way, the foot's moving that way, how do I know what's going on?
Yeah, so maybe a learning module can learn like just one movement. Like if the stapler top is opening and like whatever is rotating, at least I can learn one thing.
I think what Vivian said is
Yeah.
right. If you knew every moment in time that this was the beginning of the sequence of behaviors, and I'm going through it in the same order as I've done it for every other time, and you could somehow keep all the neurons tuned to that, then yes, you could, in theory, you could learn a complex behavior through a straw, through one learning module. I just don't think
One,
that's not always the case.
so I'm not saying I disagree with this like hierarchy and stuff. I think, yeah, this makes a lot of sense. But I guess in terms of learning behaviors, I'm just trying to understand to what degree it can solve this issue of everything's moving and essentially without some amount of voting still being necessary.
I didn't,
Because
Niels, I didn't say there's no voting. I think there's voting
yeah, okay.
occurring at every level here.
So it's more just
Right.
about sharing the models.
It's two things. It's like attending to some subset of the stack of learning modules. And when you're attending to them, when I say attending, it's not like one learning module in each area. It's like you're attending to some area. So that area is going to be voting. So you're going to be voting on, plate or logo or whatever it is. I don't know. So there'll be voting going on, but on a restricted area of the input space. And and I guess that's it. That's all I'm gonna say about that. It's still voting.
Yeah, no, that sounds interesting. I like this idea, which I think is what you're saying of like with the top down biasing the voting to basically force kind of that island of voting columns to be smaller in some way, that decision is happening at a higher level.
I don't know if it's happening at a higher level. It seems to me that we know that the restriction is going to be to anything that's changing, right? So it's easy to detect when things changing. That's what the inputs, the center surround inputs will tell you. They'll tell you when something is changing. And so I'm not sure if it's at the parent or to the child level, but any region, a set of columns are saying, hey, my input's changing right now. Let's go look at only the parts that are changing. So again, this is not a worked out theory for how we learn behavioral models. I'm just saying this is the framework which I'm going to think about it. And so I think there's voting going on still. There's some sort of restricted attention. I've expanded attention to being not just restricted area, but doing it through a stack of regions. So you're basically saying, here's a, route this information from down here up to the top. And voting is occurring at each level.
Yeah, thanks.
I guess I'm having some trouble understanding how can we learn higher level objects before we can learn the components that compose these higher level objects.
We can't. You always have to learn the components first.
Right. So maybe then I misunderstood this hierarchy. It feels like
But Rami, at any point in time, unless you just came out of the womb, you'll have something learned in these regions, right? So Link or any child, has some limit to the number of the things they've learned, and so their composite objects are going to be limited to what they've already learned. So if they haven't learned letters yet, they're not going to learn words.
Right. So at first, so we still have to go through the slow learning of lower level objects, and then we send those lower level objects to the higher level.
No, I think you can start off at the top. The very first things you imagine, I don't know, let's imagine every column, they don't know anything. All they know is like edges or something. I don't know. I haven't thought through this, Rami, but at the very beginning, the only thing you learn at the top are really simple things. Just like basic shapes or something, that's all you could learn at the top. You can't learn anything else because there's no supporting structure underneath it. So the whole system is sort of slowly builds, right? This is why this is one of the reasons it takes us so long to learn the world. Why did it take 20 years to become, or 18 years to become trained? That's a huge amount of time. because we're slowly building up all these component objects that are more and more sophisticated. Well, I don't know if I've addressed your question, Rami.
Yeah, it's just that I feel like, I mean, I could look at a car and I can see, I know that I've built a model of the car by first learning about the components of the car. And maybe after then I can forget about some of the lower level components once I've built a model of the car in my
I don't think
mind.
you would forget, you wouldn't necessarily forget them, right? You don't have to.
If they're not really used in other, like if a model of the tire is not really used in other objects, then I may actually like cluster the whole.
You're right, but typically they are, right? Typically the world, you would have
Typically
tires
they
and
are.
other objects, right? Almost
Yeah.
everything would be used elsewhere.
Right, and the ones that are not used, they probably are forgotten or clustered with the model itself, because I don't really need to learn. It's just like the spelling example that you're just saying. You first learn the letters, and then you compose these higher level models of the whole words, and then after a while you can forget how they're spelled. In my mind, the spelling is this is how you built the higher level object, and you've forgotten how you can spell it. I feel like this.
You think there's something missing?
No, I think this is how, I think this is, you're basically forgetting the lower level representations that you used to build this.
There's no reason you have to forget them. I mean, you might if you never use them again, right?
Yeah.
But I don't, like a tire on a car, it's gonna be its own thing because it moves, it rotates. So you're never gonna, it's always gonna be its own object because it's part of a behavioral thing, right?
Right. Yeah, I agree.
I suppose, like, Matt, take the let's say take the Thousand Brains logo, the little image, okay, the little swoopy lines, whatever you call that thing. The first time I looked at it, and Vivian showed it to me, I was looking at all the lines. Oh, what's the curvature? Do they intersect? I really attended to it carefully. Oh, look at the different colors. And so the day she showed that to me for the first time, when we were debating, like, well, she was asking me which ones do I like, and I go, oh, I'll give you my opinion, but now, and so that day I probably could recall all those details, but today I can't recall any of them, but I recognize the logo. So there's an example where the details of the compositional object at one point were up in my hippocampus and I could talk about them. But now they're just down somewhere in the visual cortex.
Yeah, that's exactly
I forgot them.
That's exactly like the spelling problem you were just talking about.
Right, but I think most of the world's not like that. Most of the world is, I don't forget what letters are just because I've learned the words, because the letters are used in other words. So as long as something is either a moving component or it's basically anything which is a child of another object, whether it's a static child or if it's a moving child, you're not going to forget them because you're reusing them all the time. I see a new object with a tire and I say, oh yeah, there's that tire thing again. Now there's a three-wheeled vehicle or something like that.
Yeah.
All right. I think that's enough of that. We should get on to Vivian's thing. I have to stop sharing, right?
All right. So I didn't make a lot of slides, but I'm trying to get through the first ones rather quickly to get to the main point. But I have a few just building slides in the beginning again to kind of recap the solution we talked about last time and show the general way I'm visualizing it. But just to preface it, I'm ignoring a lot of different cases here. Like right now, I'm just visualizing the case where the sensor patch is not moving and the object is moving, and there's just one sensor patch. And so there are a lot of different cases that I'm not showing now, because they're not as relevant for this particular problem I'm trying to point out. All right, so
you make me feel inadequate, like I should have done this.
I enjoy this stuff, so it was kind of fun to make this. So I'll start with the example of the moving logo. So we have the logo on a cup, which is a compositional object, and we have a behavior of that logo, which could be applied to other objects. So just for modeling where did the images go? For modeling the logo of the cup, this is basically what we're sensing. We have this logo with a cup in the world, and there's a little sensor patch, and that sensor patch sends information, like it could contain movement information of the patch. In this case, there's no movement, features and changes, things that are changing. And it can send that to the columns at the lower or higher level. At the lower level, we would recognize the 1000 Brains project logo and locate where we are on that logo. And also
Are we
orientation.
assuming that there's some voting going on, so there's more than one patch, or are you just assuming somehow it knows it's the logo?
Yeah, this is a very simple example, just one patch. It has already learned the logo. Right now it's just doing inference.
Okay. I mean, in reality, that's not enough information to infer the logo from one patch, but we'll just assume it is.
Yeah, so in this example, let's say we had moved this for a couple of steps already
Got
over
it.
this.
Okay, got it.
And so, like I said, I'm really just showing a small part of the whole theory just to get to the main point.
Okay.
So yeah, let's say we've moved over this cup and logo a bit, and we've inferred the logo, the location on the logo, and the orientation of the logo. And so we're passing up the logo as a feature to the higher level column, which models the mug and recognizes the mug. And it has stored the logo at this location, and it recognizes that it is at this location on the TBP mug. It also recognizes the orientation of the mug. And same way, it can use that to rotate the incoming movement vectors. It can also calculate the relative orientation of the logo to the mug, and also use that to recognize the mug.
Just, I want to remind everyone, we've stored the relative location of the logo at that point, right? Because the logo could be changing. So it's always on a point by point basis, right? You don't store the whole logo. You store it at some point,
Yeah,
right?
yeah, it's basically at all of these different locations, it says, oh, here the logo exists, here it
Right,
exists,
right,
here it
right. I
exists,
just
here
want
it
to,
exists.
the language bothers me if we don't remind ourselves.
Yeah, no, it's always good to clarify because
Right.
when you think of it first, you would just assign the logo to the cup and
Right,
logo.
right. It's after we spent years trying to figure out how it works. I don't want to use that language anymore. So,
Sorry. Okay, so simple enough, nothing moving it. But we have a compositional object. Those are both morphology models. And then we can also have top-down projections. So knowing where we are on the mug, we can predict where we should be on the logo. So now we have this actual moving logo on the mug. So we have a behavior. And just for simplicity, I'm going to remove all this rotation stuff out of the image. That's still going on, but I just don't want to have so many lines there. I also removed the pink line here because in this scenario, we're not moving the sensor patch anymore. We're just here and the object is moving. And so basically what's happening is we have this little sensor patch. It kind of senses how the logo is moving. Sometimes it is not sensing anything. In that case, it's sensing a static feature and it goes into the morphology model. And then sometimes it is sensing some change, some movement when the logo passes through this patch. And then that movement is passed as an input to the behavior model. And using this sequence of sensed movements, we can then infer where we are on the, we can infer the behavior and where we are on the behavior. And then kind of the main solution we talked about last time is that we can then take the inverse of the movement stored here in the behavior model, send it back down here, and apply it the same way as we would apply a movement command from the sensor to basically move where we expect to be on the logo. So basically, as the logo is moving here and we have this behavior that we recognized, we can use what we know, like we can use the stored movement to move us through the space in the logo and to make predictions of when we should sense which feature on the logo. Does this make sense?
this is a review, right?
Yeah, this is a review.
Makes sense to me. And it's very
The only-
beautiful.
I think it's lovely. The only thing I was looking at was like, well, really what I would do if I saw this logo like this, I would probably track the logo with my eyes, meaning I wouldn't be fixated at one point. I would be, I'm not sure if it
Yeah.
changes anything, but I would be pursuing the logo, and so what's actually being sent to be a little different, but it's the same idea.
Yeah, so like I mentioned, I'm just showing one scenario here.
Right.
So for example, if we were actually moving the sensor patch to follow it, then we would be getting a movement input here as well. And that movement
Mhm.
input would also influence where we think we are on the logo. So in this case,
Right.
if we're doing like smooth pursuit, that would actually cause the two to cancel out. And we just keep thinking that we are on the logo mark.
Right.
Okay, so that was all a review. Now I would get into the issue I see with it, but if anyone has questions here. Okay, so I'm gonna present them in the opposite order of how I wrote it in the document, just in case you read it that you don't get confused. But so one problem is that I see here is we still have this compositional model of the mug, but we're not moving anything in here. So what kind of predictions is this model going to make about the feature that's coming in? That model doesn't really get any information right now from the behavior, so it will keep predicting to see the logo at this location where it was stored. So I guess one potential solution could be to also apply this movement here and kind of move the same way. That way we would predict the logo at the correct time, but that only really works for predicting when to expect the child object. It doesn't really work for predicting any of the other features that are not changing on the mug, because we're not actually moving on the mug. We're still at the same location on the mug. We're not moving our sensor. So that doesn't seem like a valid solution. Another one is that, well, we are actually getting input from the lower level column. Oops. So that gives us some information, but we still don't have a way to predict when we would get this input. So there's no way of us being kind of surprised when we see the logo at a different location right now. Second issue that I think is kind of the same issue, as at least in my head, is like object deformations. So the example of a balloon is kind of the simplest one I could think of, where we have an object and all of like features on the object are changing their location, but not in a coordinated way. So with the logo, all of the features are moving together, but here the features are kind of changing in different directions. Hang on. So I messed up the slide. Anyways, this inflate deflate animation should be on this one as well. Anyways, well, we could still have the balloon model down here and kind of apply the behavior movement down here like that to move us through the reference frame of the balloon. But that only really works for the location we're currently sensing, because if the balloon now stops in the inflated position, we can't really make accurate predictions about all the other locations anymore once we start moving our sensor, because the morphology has changed completely. All the features are in different locations now. We could have the balloon model in the higher level and solve it the same way as we do with the stapler, basically decomposing it into child objects, or the same way as we solve it with the mug. That kind of works, but then we have to decompose the balloon into a lot of different tiny child objects, because all of the locations on the balloon change all of the features on the balloon move in different ways. So we would have to decompose it into a bunch of different child objects, which maybe we would have to do that, but it just seems, to me, it seemed like something to point out. And yeah, I guess both of those led me to come to a similar conclusion, that we need to have a way to update the locations at which a morphology model expects features within a column. So like some mechanism where we can change the expected locations without hierarchy, so without having to decompose it, because like there are examples where we don't have clear child objects, but it's like the direct sensory input features that are changing. And I guess the potential mechanism I was thinking of was that we have, and we talked about this before in a different context of having like a common space for all objects. When we talked about it before, it was in like, what space do we move through before we know which object we are sensing? We can't really move through like a unique location space yet. So if we had like a common space, and each location in the common space has an associative connection to each location that's unique to the object, then we could learn how to apply behaviors to that common space, kind of distorting that space. And because of these associative connections, we could apply it to any object we've learned about before, and essentially just condition at which location we should expect the feature we already associated. So we were basically moving this kind of orange bump somewhere with the behavior model. And because there are these associative connections, we would then have this unique location on the object fire at a different physical location in space, or expect this feature at a different physical location in space. Yeah, I know it's a little bit out there, but I guess that's the best thing I could come up with over the past days. And maybe you still disagree with the problem in general.
Well, I see there maybe there might be really two different problems. And the one with the cup with the logo in different positions, as I wrote, I think there's an obvious, seems obvious to me, solution to that problem that it's almost like you have to do it. And I can describe that briefly.
Yeah.
I wrote it, but I'll describe it. Imagine that the logo, I purposely said, imagine it moves quickly and then it stops at the top for 3 seconds, and it moves quickly and stops at the bottom for 3 seconds. Or 5 seconds, whatever. Not like this slow moving up and down, up and down. So it's clear to me that you would learn 2 morphology objects for that compositional object. No one has a preference. There's no reason to assume that the logos should be in the top position or the bottom position. They're both equally valid positions. And they're just sort of 2 states of the object. And so and I would learn them and I would infer them. If I saw the logo with the cup with the logo at the top, I would say, oh yeah, I know that logo. If I saw it at the bottom, say, I know that, that cup, I know that. And then I would expect it to move.
But the problem I see with that is, one, you can't really make predictions about any of the in-between states of how the logos should move in between. But the bigger issue I see with it is that requires learning the specific behavior on the specific object. So we can't just apply a behavior to a new object.
Right.
You have to learn the different key states of the object first.
Well, let me come back to that in a second, because I didn't think about it in a moment. But it seems logically to me that I will definitely learn those 2 states, and I will be able to infer them. Right?
Yeah, I agree with that. Yeah.
Right.
I guess I just don't know if it
before I understand your objection to it, let me just describe how I think that would work. The knowledge to know, therefore, within the column, that the higher level column that represents the mug, I have to have some sort of state which says, oh, it can be in this state or that state. It's like those 2 positions of the logo can't coexist. They don't happen at the same time. I don't see the logo at the top and the bottom at the same time. I don't see the top have the left side of the logo and the bottom of the right side of the logo. They're really separate instances. So I have to have some way of knowing I'm in A or B. And the obvious place for that to be is the state of the behavioral model. Right? If the behavioral model reflects the movement up and then move it down and move it up and movement down, well, the behavioral model will tell you where you are at any point in time. And therefore, the behavioral model could be a gating factor on the morphology model. It says, well, at this state in the behavioral model, the morphology should look like this. And at this state in the morphology would look like this. So does that make sense so far? Right. So now there's a continuum, right? What if there were, 5 different positions of the logo, and it stopped in each one for for so many seconds? That's one possibility. That would still work. What if the logo? But then you say, well, I wouldn't be able to predict what it looks like in between. If the logo moves really quickly, I wouldn't expect to be able to make a prediction there in some sense, because it doesn't stop. It just moves through it. And so it's not an obvious thing. So, but what I guess the point I want to try to get to is that how many morphology models we learn really depends on how many morphology instances there actually are. And it's a continuum, because things that are moving quickly and that doesn't stop, I wouldn't learn those. But things that do stop for a long period of time, I would learn those. And so it's like I don't have to pick either or. Basically, the system could be trying to learn morphologies whenever the behavior stops. But if it's moving through that, I wouldn't be able to learn that as a new morphology, at least not easily, because it doesn't stop at that position. So it seems to me it handles this issue very nicely of pairing within a single column, pairing the behavioral model with the morphology model. Now, the point of this is your question is like, well, that would work for the logo, but it wouldn't work for other objects. That's true. So it basically, the morphology model, the only thing you could predict would be the locations and the orientations. You couldn't predict the actual feature, because because if you did, if I was to rely on the actual feature, then I wouldn't be able to apply this to something else, right? So the behavioral model interacting with the morphology model, really the morphology model is locations and orientations, and that's what you can do in the upper learning module. The actual logo ID helps you infer the object, but it's not a requirement. So once I'm if I'm on a mug and there's a different image and the image starts moving and I go, oh, I recognize that behavior, then the upper learning module can predict what the position and orientation of the child object will be at any point in time, but it can't predict what the actual child object is.
Yeah, but I mean, with the logo, it's maybe a bit easier to think of, because if you apply it to a new object, it's just changing the object ID. But originally, I thought about this with the example of the stapler. It's just a bit harder to visualize or animate. But basically, if you have the stapler opening and closing, the lower column has like the top of the stapler that changes location and orientation. But then how does the high level column that has the model of the entire stapler, how does that column make correct predictions about where it should be sensing the stapler top at any point in time? Or like if the hinge behavior is applied to a new object where we haven't learned these different states yet, I guess that would be the main question.
Wouldn't the high level learning module would be telling the low level learning module the orientation it should be seeing at that point in time, right? You already had that as part of your.
Yeah, so we can do it at the lower level. We can make correct predictions about the stapler top at the lower level. But would we just say this one doesn't make any predictions because
Which one?
Can't rely on this lower level one?
Which one can't make any predictions?
The higher level one, like the composition model.
Even in our standard compositional objects, the higher level doesn't know what the lower level is.
Yeah, but it would still want to predict which features are coming in from the sensor.
No, the only feature it would so we haven't really worked through this completely, but we've sort of stated it multiple times. A morphology object is really orientations at locations. That's it. That's what a morphology object is. We then can use a feature ID to help us identify the morphology object. So the fact that there's the parent object of the mug with the logo, just not even a moving logo, has no idea that there's a logo there. It just says, what I know is that there are, I've learned that there are, there are points on my morphology object that exist at these points, at these orientations. And the child object that's currently there, I will link to it, but I don't know what it is. And it can send it to me, and I don't know what it is, but it'll help me infer my morphology object, right? It's like, oh, well, yes, if I know there's a logo there, there was some ID that came in before. I don't know what it is, because I'm the parent. I don't know what the ID represents. It says, well, this ID is usually associated with this point on my object here. And so that helps me clue into what object I'm looking at. But it's not requirement. I can still recognize everything with just my morphology model.
Yeah,
So
I mean, I'm not even talking about predicting which object ID we expect. It's really more about predicting at what locations we should expect any kind of features, even just low-level edges that come in from the sensor directly, even just low-level orientations and locations.
I thought didn't we already saw that? Didn't Niels already talk about that? That once you've, and maybe this is insufficient, I don't know, but I thought that once we sort of inferred the lower level object, then the individual predictions would be made by path integration.
Yeah, at the lower level object. So
right.
Yeah, maybe if I can rephrase, like, I think what you're kind of, I can see the problem you're raising, Viviane. Like, it's almost like in this instance, when we're using the behavioral model with the lower level, it is almost like the morphological model at the higher level doesn't become relevant, or at least is less relevant.
Why is that?
It's almost like because it's just gonna not be making very good predictions about the direct low-level features coming in.
Right, it can't. It won't.
Okay, so
maybe it just becomes like suppressed or something.
It will if the child object stops moving, and I then learn a morphology. I then do the standard compositional object thing.
Yeah.
Right?
So it's almost like a single column attending either to the morphology or the behavior.
No, think of it this way: while the child object is moving and it's not stopping, I can't make accurate predictions about low-level features. Is that true? Even let me think about that. Well, the parent object, can't tell the child object what location it's supposed to be on. But I still don't get it. Explain what my logic here is. I have imagine now I have these two columns, and let's say they have learned a set of morphologies where the behavior stops. The stapler is open or stapler is closed. The logo is at the top, the logo is at the bottom. We've now learned two separate morphology objects, and on the parent object, we know which one we're looking at based on where we are in the behavioral sequence. Okay, but I can infer either one. I can infer with the stapler open, the stapler down, so on. Now, when the child object is actually moving, I haven't learned the compositional pairing. I haven't learned a location by location pairing between the parent and the child. That's not there now. But while it's moving, I can do path integration of the because I'm sending motion commands to the child, and the child can know what to expect to predict on its own, but the parent can't tell me that. What is missing in that? I'm just not.
Yeah, so then the answer would basically be that the compositional object wouldn't make any predictions unless it had learned the kind of keyframe morphologies and was being invoked by the behavior model.
It couldn't make right. I guess it wouldn't. I'd have to think about it a little bit more, but it wouldn't. It has to start with I don't like the word keyframe because I think that implies specific purpose, but I guess we can use it as long as we don't all think it's the motion picture definition of a keyframe. But it's kind of
so basically, let's say we have the stapler, we learned the behavior on the stapler, we have learned several states of the stapler, then kind of the behavior model up here can invoke a state of the morphology model within the same column, and we can make correct predictions. But then if we observe something else with that behavior, like a hole puncher or something, we've never seen a hole puncher with that behavior before, then we have to use kind of the child object of the hole puncher, just the top of it.
Well, we would,
make
during,
prediction.
so during the static moments in time, we have a morphology model, and the link between the two is location by location. During
Yeah,
the motion portions of the time, the parent object can't tell the child object what to do, but the parent object can tell it to update itself through movement. And says, so the child object knows what it should be sensing, not because the parent has told me, but the parent has told me how the sensor is moving. And then if it stops, I start learning again. I can start if it stops moving someplace, I'll say, oh, and I'll establish some links there between the two.
Right.
yeah. Okay, yeah. I guess that that is a sufficient solution for me for this problem. Just basically kind of inhibiting the predictions of this one if we haven't seen
Well,
that behavior.
there wouldn't be any predictions, because during the movement parts, I've never established any projections of the location in the cup to the location on the child object.
Yeah, so yeah, it would basically know that like once the stapler is opened and in the open position and stopped, that it shouldn't make predictions. It should just learn a new morphology model about it.
Well, the child object will know its position, and it can make predictions, and the parent object knows where it is, but I wouldn't
It'll, I guess, try to make predictions, but then fail, and so start learning the open stapler position.
well,
Because it's stuck open or whatever for a period of time, it's open for long enough that it could actually learn it.
I don't think it, at this point, imagine we have a novel object and it's moving and then it stops. Maybe even stops halfway. At that point, the child object knows where it is in its orientation to the sensor. The parent object knows what's going on. So everybody can make correct predictions at this point in time. We just haven't established a connection between the two. That is, if the parent object had gotten to that location on its own, it wouldn't be able to tell the child object what it is. But the child object at this point says, I know where I am, and the parent object says, I know where I am. And you can, okay, well, there's no problem here. Well, let's start establishing connections so that in the future we could infer this position. That this would be a way of inferring this object in this new state by just looking at the child and the parent.
So
I don't see a hole in it yet.
we're assuming that they don't vote on a behavioral state at this point, right?
Who's not voting on the behavioral state?
Like a higher level and a lower level.
No, there's no transfer of the behavioral state to a higher level. There's no voting there. Remember, the lower level module has no idea about the behavior. It has zero idea. Just like the lower level module never knows anything about the parent. The logo doesn't know it's on a cup. It doesn't know that. It's oblivious to it.
Behavioral state from the lower level is not sent to the higher level.
Well, right now in this object, this thing here, we haven't defined a behavioral state for the lower level. There isn't one. The logo is not observing any changes to itself. So as far as it's concerned, it's a thing. It knows that it's moving relative to the sensor, but it's not behaving. It's not changing anything about its model. It's just, it's just at some point in the world, and where it is in the world is changing, but that's not a behavior. In this scenario, there's only one behavioral model. It's in the parent, and the parent communicates to the child via movement directions. It says that's how the parent communicates to the child, but the child does not know that it's moving or it's part of something else. It just says, my relationship to the sensor is changing now for whatever reason, I don't know. Maybe the sensor is moving, or maybe I'm the child, doesn't know. I don't know. Someone's told me that the location of the sensor is moving.
Okay.
Yeah, and so basically, this mug model up here, it still makes predictions about what the sensor patch is sensing when there's like static input. So like when we have this, just the white patch, when the logo is not passing through the sensor patch, it still makes the correct predictions. They still match the input that it gets. But then when the logo passes through the patch, it doesn't get that input anymore because now we're detecting change. So instead, the input goes into the behavior model. I guess it would still predict to sense a white surface, but it doesn't get any input. So there's maybe no prediction error in this case.
I'm confused. I don't understand. First of all, I never think we predict white space because I thought we're only predicting features that have, that have some.
Yeah,
something.
or like the point normal there or whatever. That was just a bit easier
Well,
to
even,
visualize.
I don't even know. I don't know what we do with. Yeah, there has to be something there. It can't be just blank.
Yeah, like the edge of the cup or something.
Okay. I didn't follow everything, but the way I'm thinking about it is think of it this way, and maybe this helps. I don't know. The morphology model is always trying to learn morphology. It's always trying to learn like what point on the child is at what point on the parent. But if it goes by quickly, it doesn't have time to learn anything. There just wasn't enough time, so I'm not going to learn it. But if it slowed down and stopped, then I can learn it. And I imagine something similar is happening in the behavioral model. If things are moving, I can learn something. But if they slow down and stop, then I can't learn anything. So I don't think there's a binary thing going switch necessarily happening here. The neurons are just trying to learn, and if they have a chance to, they will. And if they can't, they can't. They need some time to learn something.
Yeah, I guess if we just kind of accept the constraint that if we apply a behavior to a new object, we can't instantly make predictions about a new state of it. Like if we have a different hinge that just opened, if I now move to the open part, I haven't really learned what's there yet. So we would have
well, we could still use the child object for
child
that.
object. Yeah.
I understand. Even a novel object, it seems to me, even if a novel object, if I have a behavioral model, I'll be able to make predictions. So what am I missing there?
Well, if you have like a different hinge that you apply the opening behavior to, and you have the child object here for the top of the hinge.
Well, no,
and here
wait a minute, different hinge. I'm confused. Just be very. Are we talking about a stapler still, or like I've been thinking about a stapler? A stapler that looks like a hippopotamus or something. I've been thinking like, okay, the stapler, but it has a different shape to it. So.
Well, yeah, let's say the stapler, you've learned the stapler, but you've never seen it open and close, but you have a behavior model for something opening and closing.
Oh, so can we say I learned the stapler and now I'm applying it to something else? Is that the equivalent?
But you learned the stapler, but now you're applying the behavior to the stapler. You've never seen the stapler do that.
Isn't that equivalent to me saying I've learned what a stapler does, and now I see a hippopotamus and it starts to open and I.
Sure, yeah,
Okay.
yeah, it's the same thing.
Okay.
Okay, so the hippopotamus head model is up here. And so we know how it looks like with a closed mouth, and then it opens its mouth. We wouldn't really be able to make predictions yet about like where the new locations will be. Like where will the top of the
why not? I mean, well, I wouldn't be able to know where the predictions are, but I would be able to make sensory predictions. I would be able to predict what to see when I get there. Because
but you'd have to use the child object for that.
Right. What's wrong with that? I basically turned the head of the hippopotamus, it's the child object, and I've now basically changed its position relative to the sensor, and I've changed its orientation relative to the sensor, so now I can make predictions about it.
Yeah, but so then we're saying that this compositional model of the hippopotamus head would not be making any predictions at this point.
At that point, no, but as soon as it stops moving, I could start learning a compositional object.
Yeah, you'd have to learn it first. You couldn't make like once it stops moving, you couldn't make predictions about the morphology in this new state unless you learn that new state now.
I'm so confused. As the head of the hippopotamus is moving, and it stops, the lower column will make correct sensory inputs, predictions about what it's seeing. There's prediction. There's nothing there's nothing I don't know.
Right. But the higher level column, the compositional model, can only make correct predictions after it has learned the morphology of the whole head in this state.
Right. Think of it this way. If I didn't see the head move on the hippopotamus, then the top level model would not be able to predict what the object's going to look like if it was open. I'd have to know there's a behavior. And so once I start recognizing the behavior, then I could recognize it in the open position. I mean, we'll put it this way. I recognize the hippopotamus with the mouth closed, but if I see the mouth open, I would say that's not the same thing. It's something different here, you know, because I know about mouths, so that's hard to, I guess there's two ways that you can establish a relationship between a parent and a child. There's the static way, which we learn the connections from layer 6 to layer 6. That's the one way. And there's the dynamic way, where we know is the movement, and I can, based on the movement, I can now predict where the child will be relative to the parent. Those are my two options. They both work. They both work well. If I ever want to just infer the object in some position, I will have, without any movement, I will have had to establish that child-parent relationship through the morphology connections. But generally, there's two ways. If there's a behavior, then I can make all the predictions I want. There's no, I guess I don't see a problem here.
Okay, yeah, no,
Yeah, maybe.
That sounds good.
Nice, and yeah, maybe that's a good stopping point.
Well, is it, or can we talk about the balloon for a second?
I mean, I don't mind talking for a bit longer if, and yeah, I guess people can always drop out if they need to. It's recorded.
So I don't know if this is the exact same problem or not. I think it might be a different problem.
Yeah, no, like we couldn't apply the same solution to this, I would say. So in that sense, it's a different problem.
Right.
Unless
Now,
we say that we decompose the balloon into a bunch of little child objects, then we can apply the same solution.
This is, you know, on one hand, you're tempted to say, oh, isn't this the same shape, just different scales, you know? And
yeah, but I tried to show that with this kind of model here, it's not. I mean, I drew this like very exactly from this animation, that like the way it expands and contracts is like the arrows at the top are much larger, versus at the bottom they're really tiny, and at
well,
many
that's just because you
down here,
that's
there's nothing changing.
because you've anchored the reference frame to the bottom, right? Which I'm not against, but that's why that's the case. If I just had a circle that was going small to large to small to large, I wouldn't anchor it at the bottom of the circle. I could, but I would typically sort of think about the center of the circle as the stationary point, and then, or I could show it.
Those arrows just show what like a small sensor patch would perceive as
Right,
the
right. My point
in
is
that area.
because you're not showing the bottom. The bottom of the balloon is stationary. It's not moving out, and that's why you see more motion at the top than at the bottom. Right. So there's nothing wrong with that. I'm just pointing out, if I showed you a circle expand, this is not a counter argument. This is just filling out other issues here. If I showed you a circle that was getting larger and smaller, well, how would I perceive it? If the bottom of the circle was sitting on top of a desk, I would perceive it like the balloon. If the circle was sitting out in space and it seemed to expand and contract on the center point, I would think of it as different. Then I'd say, oh, the expansion is happening everywhere. That's purely a scale change. But here you've got this not exact circle. It's like a balloon shape, and it's fixed at one point. So it's more complicated.
Yeah, I mean, you can think this is like I wrote in the write-up, you can think of lots of other cases where you can't just say, all right, maybe you just roughly apply scale. Like with the balloon, once it's inflated, you can like poke it in any place and it.
I understand. I do. I don't. I just. The only reason I bring up scale is it can play a role sometimes. There are times I think we can look at two objects and say, oh, that's just a bigger one and that's a smaller one. And in fact, they could be mixed together. You could say, oh, that's a bigger version with some sort of deformation. And that's, you know, like literally a mug could be on different scales on your retina. And, you know, I don't know. It's just, scale could play a role in some situations. It's not like everything has to be handled without scale. Clearly, we use scale at times. You know, a related problem, which is a little bit simpler perhaps, and one I thought about a lot in the past, is imagining a circle that turns to an oval that turns back to a circle. It just oscillates, just like you're doing here. It's a little bit, it's the same problem, but it's a little bit cleaner. because you don't have to think about, oh, there's a little tight end here and it's, it's an odd shape. It might get at the same basic issue. It's like, well, where's, how do I learn that morphology? And how do I
I
learn
was
that
thinking first about visualizing like a ball that bounces and
Right. I went through all these a while ago, years ago, I think. But I ended up just settling on the circle to oval. Because that was like the simplest one I could think of that captured almost all the problems. But you could use anyone.
Yeah.
Anyway, that's a little bit more pure. Because I can't say it's
Yeah.
not inflating. It doesn't even have to be getting larger or smaller. It's got some shape to it. That
Yeah, that's maybe a even cleaner example.
right. I only bring it up because it's cleaner and it's one I've thought about, so I have a preference for it.
Just less easy to refer to. You can't just call it the balloon.
Well, it's just sort of like it's getting at the abstract essence of you've got this changing morphology that at every point it's like what's changing? It's like the orientation of each piece and the location. I don't know, it's continuous, right? That's the issue you're really getting at here. There's a continuous change in the morphology. There isn't like a piece moving relative to a piece. It's like there's this continuous flow of change on every point. Because you can imagine the circle becoming an oval one way, then switching it down and become an oval the other way, and then changing axes. So there's no point that's not subtly changing it, but different than its neighbor.
Yeah, so that's why I was kind of thinking of like basically distorting grid cell space by applying like slight targeted phase shifts or something like that. Because then that would be like a continuous shift that can be targeted to basically expect one place cell to fire in a slightly different location. But yeah, I don't know if
I don't like it. So take the oval and the circle, okay? So imagine that I have a circle. It turns into an oval horizontal direction. It goes back to a circle. Then it turns an oval in the vertical direction, and it stops in those 3 points. So now I have 3 behavioral models of that object. I mean, there are 3 morphology models. I could associate them with different states in the behavioral model. But if I were to distort the grid, which would be the base and which would be the distorted one? Is the circle the base, and then the oval is distorted? Or what if I showed you the oval first and turns into a circle? So when I start with the grid, it's rectilinear on the oval, and then it becomes distorted for the circle. I guess
it doesn't matter. You could learn it both ways.
Right. I guess I'm trying to make. I have a gut dislike of distorting reference frames.
Well, yeah, I also didn't like it in general, but I guess the reason why I thought it might work is because like we could, well, the reason why I didn't like it is because it would require a lot of learning, a lot of very targeted learning of how you distort the space, which is not feasible if you want to apply a behavior to any object. But if we would have a common space where we can once do this very targeted learning and learn how that space can be distorted with different kind of movements in the behavior, then we could just through these associations to the unique location space of each object, basically distort any object, and we can even anchor them at different locations on the object, and then distort different places on the object.
It's not clear to me this is really better than learning multiple morphologies. I mean, in some sense, you're going to learn.
It would work to apply it to any object at any point in time. Like you can think of like
but think about it. The balloon is pretty. I could come up with examples where the distortions, balloon-like distortions, are very local, and therefore there's a lot of. Imagine I have one of those squeegee toys when you squeeze it, all the eyes pop out. You know what I'm talking about?
Yeah.
The little antennas come out of his head. Imagine, so I got this thing, it looks like a coronavirus thing, right? And you squeeze it and all the little, all these pop out, right? Well, am I going to learn that how am I going to learn that with a distorted reference frame? I mean, That's crazy. That seems hard. I don't, you know, the story reference frames make sense when you look at something simple like this balloon or circle, but the little
Yeah.
squeezy exploding head thing, I don't think would work very well.
Yeah, I'm also not sure yet. I mean, I would have to think a lot more through the mechanism to know if this would work in general for even larger distortions like you mentioned. But I just couldn't think of any other way. Like just
All right,
learning
well,
these
all right.
technologies, you can't just apply it to a new object.
Why can't we apply the behavioral model to any behavioral model to a new object and achieve the same result? I don't understand that.
Well, we can do it if we can have child and parent object relationship and use this solution we talked about before. But if we don't really have child-parent relationships, like if we don't want to decompose the balloon into a bunch of small pieces, then that's like I don't see how it would work.
I think
How would you apply
okay.
it within a column?
So let's go back even simpler. I asked myself once, how do I recognize a circle? What's the model of a circle, right? So it's got features at locations, and those features are continuously changing. The orientation of the features are continuously changing at these different locations. And where do I break it up? When do I say, you know, it's sort of like an integration problem, right? We've defined a model where we have unique points and unique orientations, unique features, but now we have one that's continuously changing. There's nothing unique anywhere. There's no point you can say, this is where the feature changes, or this is where the, you know, the orientation changes. It's continuous. So this is a pure, simple morphology model of a circle. I think if we solve that, we'll solve this problem. You know, I can convince myself that our morphology model works for circles.
Well, I would say you would basically if your sensor senses a circle, it would still like sense the curve, like an edge.
Yeah, but how many features do I store, right? And how do I interpolate between them?
I guess you just
Yeah,
lay down
maybe
after a certain distance.
maybe a related kind of thing. Yeah, it feels like in this setting, a combination of attending to regions when it's particularly relevant, like, I don't know, a logo that's being distorted on the balloon or something, and simpler things like scale and stuff could be enough to like predict probably as well as we actually do.
Are we talking about the
Like
balloon
it's
now or the
like the
circle?
attending. I'm talking about the balloon, but basically, I think it's similar to what you're saying, which is that yeah, we need to figure out what is the granularity of representation, but it's not necessarily like a fundamentally different way of representing it.
Right. So we'll leave it, we'll have to end soon, but we'll leave you another problem to think about. This is one that really bothered me. So I was thinking about circles and how I'd represent a circle, a simple morphology model of circle. Then, and it's just basically there's nothing else. There's no features. There's no color. There's no line thickness. It's just circleness. And then it can be made of anything. Then I asked myself, what's an egg shape? Not an egg, but an egg shape. Well, it's kind of circle-like everywhere, but it's not a circle. You know, at some point my circle becomes a little distorted, and now it's like a little. It's like it's not even an oval. It's like an egg shape. And how do I recognize that? How do I know that? You know,
Well, because
our
it
morphology.
exists at different locations. Like
When does a circle become an egg? You know, that sort of tells you something about the granularity of the problem.
You mean
right?
like on the continuum, as in like
right.
you could have a morphology model for an egg and a morphology model for a circle, but what are the morphology models for the in between?
Well, sort of like, and when does it become one versus the other? Like if I show you a circle and now I slightly distort it, and maybe you wouldn't notice, and I slightly distort it again, you might know. At some point you start saying, oh, I think it's not a circle anymore. What that gives you some clue as to the granularity of the representation.
I mean, I would say you just have a model of a circle and a model of an egg, and then when you recognize it, you recognize whichever fits better with the features.
Well,
and
let's say I
location.
don't, maybe I don't even have the egg anymore. I just have the circle. When do I say that circle's not regular?
Well, I guess like
it's-
when you start failing to predict what you're going to
well,
see. And,
right. But it's like, it just gets you, I'm not saying this is an impossible problem. Maybe our models work for it, but it sort of teases apart some of the issues. It's like, then I say, well, what is it? Is it the location of the feature that's important, or is it the change in the curvature that's important? You know, or both? I don't know. But you know, anyway, I was just trying to like, how do we seem like recognizing a circle and an oval and an egg are such simple shapes to recognize, but I don't want to have this super complex model to recognize them. I don't want to have a model that has thousands of points on it. Somehow it seems like that doesn't seem right.
yeah, I think
You
that's
know.
in general a weird thing that we can maybe discuss another time. But just like how we represent surfaces and everything right now is, of course, very like dense in terms of
Right. So
the
maybe that's
capacity.
the lesson for today. Maybe that's the walkway for today. And that gets to the balloon problem. How do we recognize surfaces without being dense?
I feel like we already kind of solved that problem, at least
How do we
in
do it without being dense?
Right. Like when we store points, we don't store thousands of points on a circle just because the features aren't changing. We just have some criteria of when we put in a new point. So for example, after the point normal has changed a certain amount, we put down a new point. So basically, if the current point in the model has a point normal pointing in this direction, and then we have another one at points like 20-degree rotated, then we would lay down a new point because it's the features are sufficiently different. And then also if there's a sufficient distance between 2 points, we store 2 points. But
An interesting question would be if I drew a circle and you wanted to learn the circle that way, and then you sort the points using your algorithm. So we don't do it densely. Now,
yeah.
could I show you a 100-sided polygon that it would say that's the same object? And
You mean that it's like a circle, but all of it are straight edges?
Right. I'm testing the model, saying, okay, you've got this model where you've used this formula. There's no interpolation really.
Yeah. I think it would work because it's still
But it would have lower evidence for it. So it wouldn't say with the same confidence. No, but I think that's a good thing. It wouldn't say with the same confidence of an actual circle that this is definitely a circle. It'll say, yeah, I'm getting circle vibes, but maybe I'm going to learn this as a new object.
Every point is correct, isn't that right? Isn't every point correct?
Well, the locations
If every point is
match, but the
curved,
features don't match. Like
oh,
the curvature is different.
Oh, you're storing the curvature at that point, not just the tangent.
yeah.
Both.
All right, you're right. Sorry about that. I was thinking you're storing the tangents.
The normal is correct.
Yeah, the normal and the like the pose basically. So the location and orientation would stay the same, but the feature would be different. The actual amount of curvature.
Well, but if you sample points on the surface, so if you have the 100-sided ones, and you sample points, because the way that we calculate the curvature is from points, right? So if we sample points on the circle and we still calculate the same curvature, it's going to be the same.
I didn't follow that, Ronnie. You're saying you're saying we're not
how do we
storing
calculate the curvature of in Monty? We have points and we get the curvature from there, or
yeah, but since we have a small patch, it would probably extract like that it is a straight line if the patch is sufficiently small. I mean, if the patch is like covering half of the thing, then it would extract a curve because like.
well, I think
little
there's
edges.
an example of too many sides, then even a small patch would you'll still sample points that will give you the right curvature. So even Monty wouldn't know. So I guess the point that Jeff is raising is that there is a resolution problem where if you just make the circle have too many sides, then even Monty will get confused. Whereas
No,
I mean, to me,
not...
that sounds like a circle on a computer screen, which is made of pixels. Like
yeah.
that sounds like perceptually it would be a perfect circle, but even though it's made of straight edges.
Yeah, and also, I mean, the morphology would match So yeah, we would
Maybe
kind of
it's a
want to
good thing
say
that
it's
Monty
similar.
would get confused, because we would also get confused if the edges are too many.
And
we would-
again, I feel like if it's somewhere in between, like there's lots of edges, but it's not quite a circle, like some, I don't know, Sentekahon or whatever it's called, then I think Monty would be like, yeah, I'm getting high evidence for circle, but not the same as like a prototypical circle. And you could start learning as a new model, but you would also be able to say, if queried, like, yeah, this is similar to a circle, which is I think what we'd want.
Yeah, but yeah, anyways, I don't think this is, at least it's not the problem that I was trying to get at. But yeah, I'm getting kind of hungry, so maybe we
All right.
take
Yeah.
a pause and then
If nothing
talk
else,
about it.
I think it's a good sign that we're moving from like staplers to things like balloons and
Well,
squishy objects, because that means we're really solving the hard problems now.
Yeah,
well,
solving
I
more
don't know,
problems than we set out to.
well, we always, the latest
Questions.
problem always seems like the hard problem. So it's like, the really hard problems we've already solved, they don't seem hard anymore.